Ja. The hell? L of lead. Piecewise is just that you have a curve and you chop it into pieces. And then you solve something for each piece separately. And then you can connect all those solutions together to get the whole curve again. Now, I could of course start a for loop here that runs over C0 and then do the calculations, but in the end we just want to graph it. So it would be probably nicer to simply write a function that, given C0, calculates the relative error for also for a given n. I guess I just have to plot 4 curves, so we do need a loop that runs over all the n values. Yeah, well, it's... And at the same time, I get an upvote on Reddit. Was that you? But I mean, now it's gone. Someone on Reddit asked if they knew C++ coders that streamed on YouTube. And someone else mentioned my name, yeah. So I did add a comment, adding all the links. Let's see. Yeah, the quick graph here. It takes a title, labels, and ranges. Okay. Title is, say, just the name of the program even. Halley iterations, whatever. And then horizontally we get C0, and then vertically we get the relative error of, yeah. I don't think I can use subscript zeros here, but we'll see. And I need to pass a range. Well, I just want to run C0 every time from 0 till, let's say, 0.903 or something. And then have it automatically determine the y value, so the y range. Now let's do add function. So the graph. Function double and a line style. Okay, you can pass a line style. I hope I can also not pass a line style. Yeah, that would be this one. Then it will draw it in black. Let's begin with some. What did you see here? Some simple function that just returns what you put into it. So they did draw in 4 lines, all on top of each other and all black. Yeah, and we do get a subscript 0 here, so that works. It's more like 4. Let's do this, and I use a 6 at the end. It's just ridiculously precise. But can you really ever be precise enough? What is Python? I'm just kidding. No, because I don't know Python. I think C++ is super easy. Sometimes they invent new stuff, so like the lambdas, but although these are also already, I don't know, more than 10 years old now. Just the capture phrase and then the function parameters, and you can specify the return type with that, and then this is the function body. Okay, so the thing is now I want to probably use different colors, maybe. I don't have a built-in, what is it called? Legend, I think. Anyway, I don't have that, so yeah, I just have to remember the colors. Choose array. Start with black, well, and then RGB in that order. Now let's separate the function a little bit. I'll just multiply this with n, which means that we have to capture n. Make a copy. Beautiful. So this is for n is 1, and then n2, n3, n4. And the reason that they run out of this thing here is because the first one determines the y. So it determined the y range based on this function here, this one. And the rest runs over the window. But I think that later on n equals 1 has the smallest relative error. Oh, that is exactly what not works then. Yeah, okay, so we have to start with 4 really. Otherwise we'll run into the same problem later on if you want to make them all visible. I'm sitting in the dark, I'll be right back. So starting with 4 should make a bigger Y range, so they are all visible. But of course this is not a relative error. So now you have to create functions that do what I described. Okay, now I'm gonna have a look at it. I got another upvote. Okay, I'll show you. I got 5 upvotes on this comment. Why? Because I made another comment on whatever this guy is reacting to. See, full discussion, and then completely lost it, of course. Yeah, this one. There's only 2 upvotes where I give all the information, and it just gets 5 upvotes. Hopefully the op also saw this. No, yeah, of course he did, because that's why I reacted directly to him. Anyway. So now we have n, and we have c0, and then we have to return the maximum error that we can do, such that blah blah blah. Right, I think we just have to try that, and that doesn't fit in lambda. Let's just call the function. Create a function which we then call here. Add function simply takes a standard function, so you can also pass free functions. Yeah, I'm talking about intervals here. I suppose I could just yeah, well, I mean, there is an upper bound, which is very interesting. There is also a lower bound. However, the lower bound is equal to the upper bound of the n being one larger, I think. So really, I'm just interested, I think, in the maximum relative error that still gives that n. So I'm going to call my function max rel error. And we are being passed C naught and n. So const. Do the same thing as before. Just return n times C0 just to use the input. Yeah, and then let's call that. Okay, that doesn't work, of course. Wait a minute. Can't pass n. We have to pass a function that just takes a C naught. So it must be could be a member function of a class. How shall we do this? I need to know n as well. So let's just make it a visible thing. Let's make a class. Okay, so now an instance of this class is callable with a double, and yeah, this is what this defines. It says that we are callable, and then you have to pass that as argument. But then, of course, we have to create an instance, and then we have a different instance per n. I'll just make a instance here. And then here I have to pass something that is callable, which is then the instance itself, right? However, I'm not sure that that will work. I don't think you can pass it like that to a standard function. I mean, it's a callable class, but I'm not sure. I'm like 99% sure that it doesn't work. Let's first just try to compile this, I guess. No, that's interesting. It just works. Wow. Yep. Pretty cool. I didn't really know that. So because the class itself is callable, you can just pass an instance to a standard function. That takes a standard function, well, yeah. That takes something that is callable that way. Now this comment now, more applies to the implementation of the inst function than the main, so maybe I should move it up. So now we have to determine the value of rel r such that ... and then once we find that, just return it. But we can only do a binary search because you have absolutely no idea what it is. So you just have to begin with some I guess we just begin with a relative error of 0 on one end and then a relative error of 100% on the other end, and we'll should be able to find it. That's ridiculously big. Now we have to determine for both well, what the number of iterations are that we need using the code that of the library itself. I'll call it the library, but existing code. Keep drinking this. The juice of red fruit. I keep doing binary searches these days. You would think that already exists with support from the standard even. Hello, Daredevil. Yeah. I could just type it in, but I've written so many binary searches lately that I just want to look at an already existing case. See if that is usable here, so I don't reinvent it and or keep that kind of code a little bit consistent. I'm pretty sure that the last one that was written is inside the last function here, file, and then we're working on this. If I added two files, I always do the old one first and the new one afterwards. Otherwise, I get confused. That is 556 lines. So how do I search for that? Probably something that uses this, for example, bracket. Doesn't get any more binary search. Yeah, I had another one. I was using the golden ratio method. Yeah, the golden ratio method is really only necessary when you look for an extreme, I think. I mean, in this case, we have a monotonic change. So if my input variable grows, then the output, that is the number of iterations, also always grows. So it never goes down again. Well, if you have a function that goes up and then at some point you reach the maximum and then it goes down again, then you need a golden ratio algorithm. So we can use this, the bracket algorithm. Let me just copy it and then change it after pasting it in my new file. Just paste it here. Okay. Or maybe I should just have a separate function that does an arbitrary bracket search. So what this does is it looks for some value in this thing such that the value of this function gets close to target. That's unfortunately also not exactly what I want now. Because my target is an integer. I have to re-implement it. Yeah, this thing begins with determining the output. So let's call this n, or no, not, yeah, n. N is then the number of iterations. I could write it out, but. And then I need a function that determines the number of iterations. As a function of rel min, and yeah, also everything else that we have. And what we have is c naught, so we can pass that. And if I make iterations also a member function, then we already have n, just a member. Or could separate it out, but I might as well make it a member function, because it's only necessary for this object basically to determine the maximum relative error. Okay, so what I really want is to find the maximum value that we can pass to this function such that what it returns equals n. And if you increment it a little bit, it's higher. Which means that n min must become equal to n, and n max must become equal to n plus 1. And then bring those two as close together as possible. So as a comment, let's say we are looking for the largest value such that n min equals n. So we fail if one of these things is not true. So we demand, well, we demand something, and if that's not the case, then we throw. What we demand is that n min is less than or equal n, and n max is greater than n. And once we're done, then we must return, of course, n min, because, sorry, the rel, yeah, this is not correct. You have to return the value for which the number of iterations is still equal to n. Maybe min and max is a little bit confusing names. Could call it bottom and top or something, I don't know, left, right. Now we only need a tolerance. That is probably something also pretty stable. Let's just add a tolerance here. Tolerance. In the end, it's just going to be constant, but why not put that responsibility at the caller as high up as possible instead of hard-coded in the class. Multi-precision reel. Oh, you work with doubles here. Okay, do this thing and determines the midpoint of my current interval, where x is my relative error now. And we remember the previous y value. Not sure this is needed, but okay. So we go in the middle and then we calculate this previous never used. What the fuck? Don't need to initialize it then. Already appeared so random the 0 there. You just assign it. Damn, don't even need it outside. Oh wait, it was an int. Isn't it? Okay, so we just determine the number of iterations required in the middle. And then, yeah, I mean... there are a lot of possibilities. Why is this thing not updating rel mean? I mean, if you change n mean, then you must change the rel mean. I copied this code from somewhere and it looks like this. That's really weird. These two belong to each other. So either we move the maximum down to the middle, or we move the minimum down to the middle. And n mid is changed so that it's yeah, and mid and minimum and maximum are changed as well. Why would they even do that? Maybe that's what I'm mistaking here. Am I mistaken there? No, because you need them here, I think. No, we don't. Actually I don't. I think I don't need this. Just narrow this interval here. Okay, now when do we do what? Yeah, it's actually not, no comment is even required. And mid is less than or equal n, then it can be used as a min. So this must keep holding, and this is what iterations returns from rel r min. Thus, if what iterations returns for rel r mid, which is this, is less than or equal n, then we can use that value for rel min. So we just assign it to rel min. And if this is not true, then it is larger than n, which is then this one. Hence we can use it for rel r max. And I don't even have to update n min and n max. It's actually only used to check if it is bracketed. It's almost silly to have this, because we start at 0, which gives, yeah, 0 iterations, I hope. So it should be, well, maybe 1, but definitely not more than that. And 1 is ridiculous, so I hope to get the maximum. I'm not even sure though if that's going to be enough to get 4 iterations. So okay, let's leave this in. Then we know for sure that you have a good starting point, and then this block should work. Then we have to implement iterations, which is also a member function. Sorry, it returns an int. Takes 2 doubles, so rel r and c naught. Okay, so now maybe the comment belongs more to the class, because that's what is calculating this whole thing. I'm going to move it even up further. Right, so how do we determine the number of iterations? Well, I have to just create cubic. I'm going to, I think I'll just move the using namespace to the top. Actually, it is not in, no, I'm not sure if it is in Cairo. No, it is in math. I don't think I added to the Cairo window thing. No, I don't know. Let's put it here. Let's leave it here for now. I'm just going to use the math namespace here. So I want to use a cubic polynomial class, which we can construct by passing the A, B, C, and D. This seems to be the only way. Yeah, or form a polynomial, but it's not going to happen, of course. Nope, just have to pass all of these things. And yeah, obviously we have, this is C naught, this is -3, this is 0, and this is 1. So that's easy enough. Yeah, because we're talking about this polynomial here, cubic. And then we have to calculate, of course, our starting point, so that is the R0 value. In order to be able to calculate that, I need the actual root, however. So first we have to calculate the root, the real root of this thing. So I can do I'll just call this get roots. And I'm pretty sure that this returns R in so the smallest value in the roots 0. Well, except maybe if C naught is 0, it doesn't. I think if this is, yeah, I'm actually sure. If this is 0, then it puts the root that it finds in, then it puts 0 in this thing. But the real, R is defined to be the most negative root. So really I should use the actual value of R in that case. So if that's an R should have been minus the square root. of 3. Obviously, minus the square root of 3 is a root of this polynomial, right? If C naught is 0, and you put minus the square root of 3 in for x, then 2 of the to the power 3, so 2 of the square roots turn into a plus 3, and then the other one is cancelled. You get plus 3 times the square root of 3, and here minus 3 times the square root of 3. So now we have r, so we can calculate r0. That would be this. And it might have an influence, so I think we have to calculate for both values, the plus and the minus 1. And then, yeah, just see if both give us the smallest number of iterations. What am I concerned with, actually? The largest one or the smallest one? Oops. So suppose we have a certain relative error, and the number of iterations between these two is different. And what should I return? I think we want to be pessimistic, so you should return the largest of the two. Which means we need again another function. Or I could do it in this function and then put the thing in a loop. Maybe that's more logical. I don't want to add yet another function. Certainly not if it is also called iterations. Let's make an array here, size 2. And then, yeah, then we put the -1 up front, I suppose. Stupid arrays need 2 braces. Never even understood why, but it has to do with the fact that arrays are oh god, I lost the word. No, I lost. It's just gone. I'm going Alzheimer. I'm sure of it. I do know the translation of the meaning of the word is at least it does not have a constructor. An array does not have a constructor. Therefore, they could not make a constructor that takes an initializer list. So you have to. Yeah, I don't know. That's that. In the end, then the only way to get it assigned the way you want is with 2 braces for some reason. Okay, so now we have to use the R0 from this array for twice and then fill in the number of iterations for that. So now we have to calculate the number of iterations and even knowing the plus or the minus to use. So now we have R0, which now means that yeah, R0 is the starting value. So let's just do the Halley thing. I hate to do code duplication, but my cubic polynomial, or rather the get roots from that, I do have support at the moment. There's code duplication. Wait, there's already code duplication. I do have support for returning the number of iterations. Maybe I should just also add support, at least in debug mode or something, or I don't know, to return, to pass the initial value. Or we can just copy the code again. Because we don't need any of this then. This is where we want to start, I think. No, not even that. Yeah, this from here. So we have now the U is the initial value, and then we have to duplicate this part. That's all actually. I don't even need to calculate the root anymore. I don't need scale or ix. We just want to know when it stops in terms of number of iterations. Oh, but wait a minute. I do need C1, I know what C1 is. This is calculated from U, and that is calculated from U in C1. Yeah, it's all self-sufficient. We just need C1, which is -3, I think. Yeah. Yeah, I'll just copy it, I guess. Copy this whole thing. So here is the cubic, C0 plus U times C1. So C1 is -3. And then plus U to the power 3. Okay, limit util square. Do I want to print this? Still didn't even define my terminating condition yet. So how am I gonna count the iterations then? Shit, I need a good termination thing here. Definitely never want to reach the limit. But well, yeah, but now that would mean that we terminated on that step is equal to 0. Daredevil says, will you sometimes show your setup? Well, the only thing you get to see is my NeoVim editor. This is console. So I run Arch, and Arch comes with a package called console. That is the terminal that I use. And inside that I run NeoVim. And the configuration of my NeoVim is partly on the internet. Not completely, I have to admit. It's not, yeah, I don't know. It's not that much special about what is not on the internet. But the colors and stuff is on the internet. And then I use Fluxbox as a window manager, but yeah, I mean, you wouldn't be able to see it if I use something else. It's just a window is a window. Isn't it? Yeah, now I know what I wanted to show. It's actually currently I'm using the Deja Vu Son Mono 16 point as a font. But that's for YouTube, so if you're half blind, then you could use this. And otherwise, normally I use this font, which is this is called Hack 12 point. Yeah, that's in terms of the font. I'll switch to YouTube again. And then we were looking at what? Oh, I just have to go to the repositories. No, this one. There, my color stuff is described in this thing. Still, yeah, I need some IQ. You know, it's not. It's never easy. If I put someone on the internet, you still need a brain. But all the information is there. So if you don't get it, then it's your own fault, and you have to study harder. It's not, you know, a click install and I'd call that plug and play. But it took me weeks and weeks to figure out the syntax highlighting myself. I mean, I really studied how the syntax highlighting worked. You know me, I put a lot of time into something when I want it. And then I don't have time left for the documentation. You just have to figure it out again. It was damn hard to get this brace, for example, to have the same color as that part. It's not trivial, but yeah, I wanted it. It's just going to compile. Let's just try it out. Added iterations. It doesn't know what cubic polynomial is. My initial value is not called U. If the result, put the result in N, or the number of iterations in N. Oh, we already do that. And I have to pass the tolerance. No, the maximum limit was set to 10, and clearly it doesn't terminate. It just alternates. Oh, that's why I used the previous thing. Yeah, I don't know how I lost that then. So we have here C0 is equal to 0, I think. So this is simply minus the square root of 3, which is just the bang hit in 1. So we should have 1 attempt. I mean, before you know that you're there, you have to at least go through the loop once, and then we should terminate, period. We should terminate because this is so small that we should terminate. But, yeah, I was like terribly lazy. And what I actually did is just I let it keep running until it doesn't change anymore or something. But the thing changes continuously, just alternating. It never stabilizes at a certain value, and therefore it never terminates. How many digits is this? Is it only 14 or 15? I mean, you don't see the change. It's like as if it's not printing everything, which is quite annoying. At the very least, the precision is set here to 15. I want to see everything. That is, I want to see everything, yeah. There is a numeric for it, but might as well hard code it in. Figure out when we do to get to see, if we get to see it, and when. It's still not showing the delta here. So let's add another one then. I'm sitting in the cold here. 18.5. Yeah, now we see toggle bits. So the actual value appears to be 773, but we go around it. So what is the high precision value of the negative? Well, the negative don't care, but the square root of 3. So I do the square root of 3, yeah. That's not precise enough. There we are. So this is a accurate square root of 3 thingy. Well, what the fuck? Oh, that is, I was looking at the wrong place. So 88729. So yeah, round that off to 3. So it toggles around this 3 here. Then I suppose this is accurate enough. Let's see if I do one more one more position. I mean, more than 18 is definitely not interesting, I guess. Oh, okay. So now you can actually see that the difference there is 42 minus 19 is 23, and then divided by 2 is 115. And that prints here 128 instead of 115. Now we have more accuracy. We print more accuracy than we have, but okay. I like it this way. So yeah, it never stabilizes, apparently. And let's print the next value that the next largest value that fits in a double next to this thing, to see if maybe we can terminate on that position. So we're going to print something like that. Let's put it on there. What is it called? I have no clue. That's a question for ChatGPT, because I can't remember it. Next after. So this is what I really like about ChatGPT. If you type something, you mumble something, you vaguely know what you're talking about, but you can't remember anything about it, then it really understands, well, between fat quotes, what you're saying well enough to come with the answer. So if my memory doesn't work, then ChatGPT understands whatever I type in. Well, if I paste this, say, in Google, now I don't know if they secretly use an AI here, but okay, the third link or something. So we would have found it as well by just pasting that in this case. But you have to do a little bit more work, apparently. Just a little bit. Where's the thing here? So yeah, I want to search for standard next after now. It's even colored still. Can you imagine how bad my memory is? I used it, I don't know, a few days ago maybe. So next after is 1. It's described as if from equals to 2 is returned. What is from 2? The library only okay. Okay, maybe not okay. Let's have a good example here. No, I just use infinity. If that works, then it works, doesn't it? Okay, so we want to do here. And then it doesn't fit on the line, and I blame you guys because this is a YouTube font. Next after value, and then that would be just you. I said you. Yep. So it just toggles the thing after this one is exactly that one. So it's literally the last bit that is going up and down. It's just one bit. So I guess we could terminate if the difference between these two equals that one bit. So how would I find that out without too much calculations? I want to have this value. Or something close enough. Now in this case, say I would get this, and I want to terminate as well. Sorry, I don't get this. Well, actually, this is already the case. I get this one and I had that one. So at this moment, I want to know that, well, I could compare this with that one. That would be exactly equal. Okay, it could have been the other way around though. So then we need, at this moment, we need to remember the next after, but also the one before that. Next before or something. Oh, it's just a direction. So you do minus infinity and then you get the other one. I don't know how slow this thing. It should be fast, right? This should be super fast. Theoretically, you just toggle a single bit somewhere, I think. I'm gonna assume 1 clock cycle. So step is unequal 0, also unequal that distance, which then means the absolute value step is less than, or larger than that distance. I think the absolute value is super fast. Just resets the sign. So while it is larger than some epsilon, and then epsilon must be set to that single bit, the value of that single bit, more or less. these. How do you do that? No, I don't want to do it like that. So if step is larger than 0, I mean if it is 0, then I don't even care, I just terminate anyway. If step is larger than 0, then u became larger, so now u is larger than the previous u, and we get the next largest value after previous u. So if that's literally that last bit, then now near is equal to u. Okay, so now determinate, yeah. But it still did 2 iterations, apparently, which is kind of stupid. Yeah, that's kind of a waste of CPU, isn't it? So we had to do that, otherwise previous u is not defined. So this method only works if you have at least 2 iterations. If you want to stop after a single iteration, then we really have to just look at this value and say, okay, that's small enough. That is maybe the better solution then. I could make a reasonable guess what this value is, because our starting value should already be almost equal to the root to begin with. That's my aim. So you can determine what this distance is, basically from the initial value already. So let's attempt to bring this down to a single iteration. Can't do any less. by, that would even be better in the sense also that then I can move that outside of the loop. Let's not have near. Check it. I'm going to define an epsilon, which must be positive, I guess. Epsilon is the absolute value. No, that is not necessary now. I just simply take the next after in the direction of infinity of the initial value, which is u. Minus u. These are different, so it's impossible that this is ever 0. In fact, it must be larger than 0, always. And then I don't do the near thing. But yeah, now we are in the realm of rounding errors very much. So I probably have to multiply epsilon with something after taking the difference. We have position again, and I can just multiply it with 1.5, I think. But then, of course, you want to print it, what epsilon is. I guess it worked, or not? No. It's printing epsilon twice. Oh, we could, huh? Oh. Looks like you print this twice for the call, for one call to get roots. That would mean 2 loops, if you ask me, 2 iterations. Why is epsilon printed twice? What did I do? Printed outside the loop here. Strange. Oh, what? No, yes. Ah, what the fuck? I'm thinking about, yeah, that's code duplication. That's the reason. So we don't have it prints this, and then we do this twice. So the iteration is now 1. Epsilon gives it, so I already had an iteration of 1, because I saw Halley being printed twice. Yeah, I guess we did, of course. You immediately define previous view. Okay, so my previous code was maybe still better than this. It feels like gambling, this epsilon stuff. Well, the other one, it was like literally continue until the difference is a single bit or less. Which I can imagine would still not work, by the way, but then the epsilon wouldn't work either. I think I would rather go back to the other one, although then I have to do the standard next after inside loop, but I'm aiming for like, yeah, I don't know, man. We're aiming for reducing clock cycles here, right? To have a division in it. I'm aiming for 2 or 3 iterations at most. Yeah. If the epsilon method works, it to be faster. So let's try it like this. Could add an assert maybe, that it never fails. Let's add an assert for it. So this should test that if... No, let's do it first like this. If yeah, oops. You can go the other way around. No, just use previous view. Yeah, no, this epsilon looks a bit too large, doesn't it? I mean, it looks more than even twice this value, which is, yeah, it's just not good. And still we finish, still we stop after one iteration. And we don't assert on the assert that they just added. Confusing. I'd expected this to be 1.5 times. No, wait a minute. It should be less than that. You should have divided it by 1.5. This was a 1-bit difference. I'm going to remove my 1.5 to see if then at least they will be equal. More or less equal anyway. Jesus, what a big difference. How the hell is that possible? It's not possible. Is that possible? No, it's not possible. I don't get this. Huh? Sometimes you just have to print a shitload of debug output. To understand what's going on. Hey, Koto. You're here again for the music. What is going on? Initial u is minus the square root of 3. Or is it? And then if you add 1 bit to that, you get this one. And the difference between those is 2 times 10 to the power minus 16. Yeah, it was a joke. I never have music. I would like to play music, but there's 2 problems with that. One, my account would be banned because people want to make money with music, so they don't want anyone to listen to it. And two, then I would play music that I like. So if it is stream something without music, then everyone can put their own music in the background. It seems much better. I'm listening to this now. Oh, it's not connected. Never mind then. Oh, I'm listening to music. I always listen to music. Yeah, currently I'm only interested in the top. So the distance, the next after my initial value is 2 times e to the power minus 16 further away. And then we do single iteration, and then of course the previous u is equal to that value. And the next u is, well, let me see, is it larger? It is larger, right? I mean, oh, it's more negative actually. So it's smaller. So we did go the other way. That's kind of unfortunate, I suppose. I'm looking at. I'm trying to get and implement, determine whatever a good termination condition for the Halley method iteration. And being the perfectionist that I am, I want to let it run until there is no improvement possible anymore. That means assuming that there is no noise, and there shouldn't really be noise in my opinion. It should get closer and closer until it's basically just one bit wrong. Yeah, so you have a certain double with a certain value in it, and then if you make it one bit to the next. There is a standard function for that. Next after. So then you get the double that is larger, but there is no double that is in between those two values. Just the next value, the next possible value, just epsilon larger. And the weird thing is now that if you start from this value and you go to the next largest value, then you get this one. So the 7 changes into a 6, goes towards 0, so it's larger. And the difference between the two is then 2 times 10 to the power minus 16. While if, and this should be also a single bit, if you go negative, so the next possible value for a double that is less than this value is equal to that, and that difference is minus 1.28. So and now I ask myself, How the F is that possible? If you go one bit up, you do 2 times 10 to the power 16, and if you go one bit down, you do 1 bit times e to the power 16. Incomprehensible. Yeah, I guess that is a good word then. Representable. The next value that is can be represented in a double, but it cannot be equal. It's the next largest value that fits in the double with this position. But I don't want it, I have it. It's just the standard as a support for it. Let's change the code just to be sure that the other value is indeed what I expect. So this, I went towards 0 now, towards plus infinity. Let's go towards minus infinity here. See, so I have an initial u value, which was calculated before, print that. And then I print what next after returns, which means that just just 1 bit is changed. Okay, so as a matter of speaking, it could of course be more bits, but it makes it the smallest possible step towards minus infinity. And we print that too, and then I subtract those two from each other. So I have to change this one as well now to minus. And then, yeah, I want epsilon to be positive, so now we have to do u minus that. And then here we do a Halley iteration, calculate the step, add that step to u. And then, oh, wait, oh, I'm getting it. This step is not this is not really the difference between u and previous u. It's what I add to it. So you can add something, and then the difference, it's just as long as this step is more than half of the epsilon distance between two possible values, it's going to increment it with that epsilon. It's not pretending that this is 0. It's going to pretend that it is equal to well, epsilon, let's say. So if step is larger than the half the value of epsilon, that is probably already actually incrementing it to the next value. That's why step can be, well, kind of significantly or almost a factor of 2 smaller than epsilon. So these values are indeed not going to be equal. I think, thank God, that I get also 2.22 or something if we go the other way, which I'm now doing. Let's print that out. Yep, 2.22. Very good. And now you see that value, see? So now you go towards minus infinity. So after this, that is the next value towards minus infinity. And then this is the difference between those two. This value is just equal to that one. That's the previous u now. And the newly calculated u is this, which is infinitesimal small step down from this one. They can't any smaller. But the delta u is what we added to it. So this is not the difference. This is just what we added to u in order to get this. I'm getting it now. Now, I have to think about how to determine the termination then. Okay, that's it. Assume a good round off. That means that if step is exactly equal to epsilon, it's going to add exactly epsilon, right? I mean, let's define epsilon for now as the difference between the next after and the value that you pass to next after. Maybe another name is better. Nah, let's call it epsilon. Yeah, but I already used epsilon. I'm gonna call it delta. Okay, delta is the difference between two double values that are super close together but not equal. So if then step equals to delta, then of course the difference will be equal to delta. But if step is a little bit more than half of delta, then also delta is being added. And it is a little bit less than 1.5 times delta, then also delta will be added. So the step is worth going back if the step is larger than 1.5 times delta. So my 1.5 was correct. And it just seems more logical, I think, to use to go towards plus infinity. Okay, that's my reasoning now. And that's what we saw. So if the absolute value of the step is larger than epsilon, then it was more than a single resolution delta. So, and just do another iteration. I'm going to print here a little bit more information as well. I think I should print the delta U as the actual difference. Let's say step, print step. And then we print delta U as the difference, so this is U minus previous U. And this is just sanity check, basically. No, not the sanity check. Did you read the description below the video? Aman? But yeah, so you have to read the description, which says what I did previously, and then that I got it working, and then what I'm working on right now. And then in more detail, I have it. Okay, see you at Qatar. Bon appetit. And then I wrote, no, that's too much. I can't paste all that. Well, you can read this as well. So I'm just trying to find the relative error for the initial value. That gives me a certain number of iterations to get a feel for how precise it is needed to make my initial guess. Let's say I could use a polynomial approximation of a third degree to get, say, 2 digits, and then the number of iterations is 3. And then if I take a 5-degree polynomial, then maybe I have not 2 digits but 3 digits precision. But if that gives the same number of iterations still, then yeah, that doesn't make any sense to use a 5-degree polynomial. in order to make that decision, I just have to figure out what the relationship is between number of iterations and the relative error in the initial guess. Or maybe the absolute error, I don't know yet. Okay, I was running this. Now we have a single iteration here. And here also a single iteration, so that's good. And then it prints as if epsilon is not defined at all. Or what? That usually means that you didn't define it. That's weird. I'm from the Netherlands. Previous due is 0, minus 0. So I'm not getting this. No, the whole u is 0 value makes no sense. It should always be less than minus the square root of 3. So that's where it goes wrong to begin with. Because the reason is that this thing returns 0. Which is kind of wrong then. I had expected it to return 0. And then we adjust it. But it prints like it is 0. And then returns a u of minus 0. What the heck? No idea what's going on here. Well, you heard me gulping down all this red fruit juice. I'll be right back. Okay, so it's impossible that it returns something close to 0, except 0 itself. I mean, even going to the bathroom didn't help. It's just not possible. And it's fucking cold here. I turn on the heater. And no, I'm not so poor that I can't heat my house. I'm just an asshole who doesn't want to get up. And now I got up anyway, I turned off the heater. Okay. So, did I put my breakpoint in yet? No, I did not. Breakpoint. A bit lazy, but hey. Run. Continue. Up. See, being called from... what is this? Get roots. Oh, the double get roots. 2 bloody breakpoints. Okay, this is the second time we enter, now it would happen. That is, I can do finish. And then we are, well, maybe I want to know what this thing returns, yeah. Maybe I just want to print coefficient 3. Shocking. Oh no. That is coefficient 3 is this one. We want to know what is coefficient 0. Totally 0. I hope. So yeah, this is the polynomial. Well, that is the square root of minus the square root of 3 is the root here. That's what I should return. Now let's divide everything by 1. What? No, never mind. This should not do anything, right? C2 is 0. Nobody knows what M is. Square root of D, that should be exactly 3. And then we calculate C0. What is M? M is exactly 0. So C0 is totally 0. Next, print C0. Absolutely 0. If AI likely, C0 is unequal 0, but no, it's equal to 0. So, what happens? That means we should skip this and keep U equals exactly 0. I want to print it again even. Let's investigate what the debugger thinks about this. Yeah, okay. So now it means that U is 0 and IX is 0. Oh, IX is minus. Oh, okay, you have 2 different types of 0. Why is IX minus 0? That makes it minus 0. But that should still be equal to 0. Minus 0 is also equal 0. Okay. Oh yeah, I set it to minus C2 was 0, so this is minus 0. Divided by 3 is still minus 0. Okay, so my root becomes minus 0. That's really silly, but okay. Acceptable. Because minus 0 is equal to 0. Just... I'm sure I saw a minus 0 there. And now suddenly it's no longer there. That's weird. 0 plus minus 0 is 0? Well, why not? Now we calculate the other two roots. So now roots out is 0. And then here is our minus square root of 3 and plus square root of 3. But, okay, there is a 0 in index number 0. Let's finish. Thus, if now I do next, then R is 0 and C0 is also 0. And then I set R to minus the square root of 3. Gee. I'm not even sure if this was the one. Oh. Oh! No. What? Wait a minute. Oh! 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 The rel error is just insane. Insane big. Yeah, maybe 1 is a bit much. So that's how we get 0. Yeah. Just, relative error is so big that you get 0 here. Yeah, and that is problematic because then it will find 0. So we yeah. So Halley, the idea was to go so far from the solution, the root, that we would take a lot of iterations. But we went so far that we ended up on another root. So this took one iteration because, well, this is a root, thank you. Yeah, but that was not a root that we were looking for. Okay, I think I'm gonna stop streaming because nobody wants to hear me eat, smack. Or I could, well, you know what? I could just continue streaming because I don't care. Everyone can stop watching, or you can watch me play chess while I have my microphone off and eat, or I can eat while watching a movie. That's what I usually do. Tough decision. Play chess or watch a movie. I'm gonna get my food. Okay, with the last one. What more do we want? So, well, if I eat and play chess at the same time, I'm probably sure to lose. Because then I put a lot of time into putting food in my mouth. Okay, I'm done eating. Let's try 10th. What? 90? Well, I didn't see that scroll over my screen. Apart from that the limit was set 10. Right. Shit. But no way, man. Oh, confusing. It used to be 100. I think I have 100 minus limit instead of 10 minus limit somewhere. Yeah, it should be 0 then. 0 and 3. Those 0 would only happen if C0 is 0. Which is this? Yeah, okay. Well, that's the book. The book has been identified. So I have 100 somewhere. That should 10. Should be 10. So we'll use that one. No, what the F? No, That's what I wanted to see. And it is not correct because n is 4. Yeah, I guess it's just it's a good thing, I guess. It's a good thing. It just can't ever get it to be that bad. Sort of. Okay, different approach. Let's set this back to something big. And then I just reject trying a value less than 1. Maybe I should just calculate it. Yep. I want this to be such that the initial value is a little bit less than -1. So how did we calculate the relative error? Like that. So I want this to be a little bit less than -1. So I need the R value in order to know that. And this is going to be more negative. Let's say definitely more negative. So let's move this. Let's move this to the other function. Here. And then I pass R as well. Well, this is the root. The root is always less than minus square root of 3. Less than equal. Okay, so now I have the root. And then we want this thing to be, what was it? The absolute value of R minus 1.001. Divided by R. That is R Yeah, so basically this is plus something a little bit larger than 1, where R is less than minus the square root of 3, which means that the absolute value is going to negate this. So we get minus this, minus that, divided by R. Which then should be positive. I'm going to do minus minus 1.122 something divided by R minus 1. Yeah, because if we pass this to, hold on. If we pass this 2 iterations, then this is rel error. Then one of these two, at least. So one of them is going to be this, and the other one is this. Where rel error is the thing that we passed. Right, so here we have 1 plus something minus 1. Well, this is just a plus, so I can remove the parentheses. And here it's a minus. So, well, this becomes a plus. This means that this becomes a 2 in this case. And this becomes a 0. And then the 0 drops out, of course. And you have r times something minus r. So this one becomes what do you want? And the other one becomes, well, this is a plus. The other one becomes 2 times r. Plus 1. Which is pretty negative, because r is less than minus the square root of 3. And both are less than minus 1, so no problems there. But I probably should add an assert for that, just to make sure. It's so hard to make any progress here, it seems. Okay, now we have 1, 2, 3, 4, 5 iterations. That's more than 4, so that's good. And the other one is 1 iteration. That is what we want. One less than or equal 1, and the other one larger than, well, yeah, larger than 4. Larger than 4? Yeah, I think so. And this one, yeah, I took something that that seriously takes a lot of steps, apparently. Or doesn't it? What the hell is happening here? Delta U gets larger and larger. What? Yeah. they really managed to get a lot of iterations like this. That's a good thing. You just go to increase the limit drastically. Nah, come on, we should stay within 100, right? Otherwise, maybe I should go a little bit away from the -1 again. So, by being very close to -1, we are in the maximum of the cubic. -1 is the maximum of the cubic, so super close to that, the derivative is almost 0, which means that Halley has a problem, so we get a lot of iterations. And there we are. Well, actually, not still not. Oh, it's something else. The Y range is now 0, 0. Why is the Y range? Why is the range 0? Okay, let's just suppress the debug output of this thing. I just call it to get the actual root. Hoping it works. I think it works. Unless it doesn't work. Yeah, probably doesn't work, does it? Because inside this thing the limit is still 10, which is not enough apparently. Let's remove the limit completely. Or, yeah, let's do 10,000 or something. I'm not really using the number of iterations, but this thing just tries to continue till step equals 0, which doesn't always work, we found out. Tja, it was in debug. So yeah, if we pass, no, wait a minute, it's, yeah, so the relative error of 0 as initial step, apparently, should give a single iteration. Maybe I should print a number of iterations to make it a little bit more clear, but yes, this is just one iteration. And then for the other initial u, which is the same, also one iteration. And then now we want to have a lot of iterations, and especially if the initial u is super close to -1. That was the whole idea. And indeed, that gives us a lot of iterations. That looks good. However, it should be looking for, with binary search, for a case where the number of iterations is around 4 in this case. So I don't know why it just stops. It just does it one time and then no binary search whatsoever, it seems. Strange things are happening. It looks like this loop is not looping, because that should have called iterations so a lot more often, it seems. Or at the very least until this approaches n. Doesn't seem to happen. Let's print the entering here as well. And deout entering also increases the indentation, so that's even just because of that much easier to read. Yeah, and n is also set here. So we should now see that per call to this function, how often it prints that iterations is called. And it should be several times, of course, until the rel r max and min become very close. So this is entered, and then we call iterations once, twice, and that's it. Yeah, that's bullshit. Bullshit. I have to debug this before I understand that. Let's have a look at the top. Now, the very first time, number of iterations 0. That's not interesting. But that's for that one. For this one, we have something that is just way more than 4. Is that the reason to stop? No. 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 Even for C0, well, we should see something, some narrowing down. We're looking for 1 iteration, not 0. And we're looking for 4 iterations here, not 13. So this is just not working. Let's put a breakpoint there and then see the very first call already. Does that work? Apparently. Entering with C0 equals 0. We begin with n is 4. Okay, tolerance was what I set it to. Now yeah, the root should be the square root of -3, but it's gonna return 0, so I just set it here. Minus the square root of 3, I mean. And then we set the relative R min to 0 and the relative R max to whatever this is. Oh, that's negative. What the F? Oh, yeah. Huh? I was so sure that it was positive. Well, if you divide this by the 1.7, then it's gonna be less than 1. Plus both, no, well, this is minus 1.7, I mean. But then it's positive, the whole thing, but not larger than 1. Then you get something negative. Something's wrong there. Let's start fixing that. 131, quit, yes, VI. Yeah, I mean, probably exactly the other one. Let's see what that bloody formula was again. 131. Yeah, that. But let's look here instead. Not this one. Yeah, I just have to take the absolute value. Yeah, works. Interesting. There's just one graph though. Oh, it's still working, of course. I think, maybe. Are we going to get another graph? Yeah, blue is 4 iterations, or maybe it's still calculating the 3 iterations. I'm not sure though. Let's quit. Yeah, finally something really CPU intensive. Now, print the debug output of this is gonna take even longer. But at least, oh, there it is, and it stops. Okay, yeah, I was gonna say at least you can see if it still calculates something or not. Well, I don't like it because I want to see all the graphs, not just this one. Why did it stop? And blue should be 4 iterations. Why is it printing 2 iterations here? How is that even happening then? I do have an N. Oh, N is 1. Yeah, cool. See? So it narrowed. Yeah, that works. Yeah, look at that. So with this initial value we have 1 iteration, and with this initial value we have 2 iterations. And they are super close. I don't. Yeah, well, you have to look at the relative error, which is this thing. That is also pretty damn close. Very small though. I think I know what is going on. The others, the blue one determines the Y scale, and the others are just out completely below it here somewhere. I have to set it, the Y range manually. Let's set it to 0 to 0.355. That's damn close to 0, it seems. Relative error, 1 millionth. Oh no. Maybe I should do a log plot instead. Print a logarithm. More and more dirty then. Nah, it just... You can just set here a Y range from 0 to 0 point, and I forgot what the value was. Shit. Trick. It's not sharp. It's literally so unsharp. I'm looking at my own stream. Haha. And it's so unsharp I can't read it. Dude. It should be HD. It's completely not readable. YouTube is a big asshole. Ah, 0.355. Okay, now I could finally read it. me. Yeah, one iteration does not happen or something. Yeah, well, I'm definitely drawn to this one, which is then 2 iterations. And it's almost horizontal, which means that we have a relative error to work with, apparently. So I have to adjust my remesa, how the hell do you pronounce it? Ramey, I think. I know French. Yeah. Well, depends on which year you're born in, I guess. The only French I know is from a song that was popular when I was young. And that is goes, voulez-vous avec moi? Voulez-vous? Yeah, I think that's it. Voulez-vous avec moi? Wil je met mij slapen? I mean, in English is... well, basically, do you want to sleep with me? So, yeah. Very popular among the kids and teenagers. And the voulez, you write it like V-O-U-L-E-Z. So, and rame is R-A-M-E-Z. And then assuming it's pronounced like in French, I would say it's rame. The rame algorithm. Now we want to know this value, of course. It's a nice graph and all, but what is this value? We have to be better than any of these values. So it's a tiny little bit below it. Or you do just one iteration more. Nah, we can reach this. We can do this, I think. This looks like it is even more than 0.01. I can easily do that. Probably even with a cubic. Can you imagine? I'm surprised though. Like seriously surprised. It's not what I expected. Okay, let's see if I can reproduce this with, let's say, just n is, I think it is two iterations. Then I don't need my y thing anymore. Pretty noisy, man. As a result of floating point round off errors. And if you change the value a little bit, it's a pretty big necessary change in the absolute error in order to have one iteration more or not. Yeah, it's all. I mean, the fact that it stops after 2 iterations it depends on a single bit in the double, so the least significant bit. So it's super sensitive to input, I guess. So the noise is kind of to be expected. And I'm gonna say just anything less than 0.012 is definitely going to be 2 iterations then. Okay, I'm gonna change the title of this. Maybe iterations is a bit too vague now. Yeah, I need to use toString. Does that still fit, is the question. Yeah, maybe I should just suppress the debug output now. Just slowing it down. See if that makes a difference. Otherwise, we'd have to compile. Oh, that's, yeah, that makes a difference, I think. Well, it clearly totally fits. Maximum relative error in initial guess to get 2 iterations. Awesome. So I'm going to write that down. Rel error must be less than or equal 0.012. And then I have to fix the Ramey algorithm to do the relative error instead of the absolute error. So, the Ramey, I thought it was an A. Ramey is an iterative technique, which I know that. Ramey step 1, Ramey step 2, iteration. Now we find it. Rational approximations. Okay, I thought he was going to talk about relative errors. Yeah, let's just read it. If we wish to extend the Ramey method to a rational approximation of the form, the function is now a rational expression of 2 polynomials, where p and x are p and q are polynomials. Then we proceed as before, except now we have n plus m plus 2 unknowns. If px is order n and qx is order m, this assumes that q of x is normalized so that its leading coefficient is 1, giving n plus m plus 1 polynomial coefficient in total, plus the error term e. Okay. So n plus 1 to fit p, and just m to fit q, because you assume that one of the coefficients is already known. And yeah, why not? Divide by the whole thing. So we might as well make this one monic. The simultaneous equations can be to be solved now are that. Yes. Really? Yeah, okay. evaluated at the n plus m plus 2 control points. Unfortunately, these equations are non-linear in the error term. We can only solve them if we know E, and yet E is one of the unknowns. The method usually adopted to solve these equations is an iterative one. We guess the value of E, solve the equations to obtain a new value for E, as well as the polynomial coefficients. Then use the new value of E as the next guess. The method is repeated until E converges to a stable value. These complications extend the running time required for the development of a rational approximations quite considerably. It's often desired to obtain a rational rather than polynomial approximation. Nonetheless, rational approximations will often match more difficult to approximate functions to greater accuracy. And with greater efficiency. Then there are polynomial alternatives. For example, if we take our previous example, an approximation of e to the power x, we obtained a 5 times 10 to the power minus 4 accuracy with an order 4 polynomial. If we move 2 of the unknowns into the denominator to give a pair of order 2 polynomials and reminimize, then the peak relative error drops to, well, 1/5. Yeah, I said that. That's 5-fold increase in accuracy for the same number of terms overall. Practical consideration. More treatises. What? Never heard of that word. On approximation theory. Most treatises on approximation theory stop at this point. However, from a practical point of view, most of the work involves finding the right approximation form and then persuade the method to converge to a solution. So far we have used a direct approximation. F of x is R of x. Well, I didn't. But this will converge to a useful approximation only if f of x is smooth. Yep, that's why I used something that looks smooth to begin with. Well, that was my half of my smoothing function. I'm still not happy with the whole thing, but okay. In addition, round-off errors. Blah 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 blah. Closer. Split f into a dominant part that you can compute accurately by another method, and slowly change the remainder width, which can be approximated by a rational approximation. You might be tempted to write g is the dominant part of fx, but fxg is approximately constant over the interval of the interest. Then the f of x is the g of x times c plus rx. What? Oh, because it's more or less constant, so they implemented as a Taylor series, whatever. Something that starts with a constant. And then r is much less than the c. You'll get a much better solution as c is a constant that is the approximate value of f divided by t, and rx is typically tiny compared to c. See, I got it, because that's what I thought. In this situation, if r of x is optimized for absolute error, then as long as its error is small compared to the constant c, that error will effectively get wiped out when rx is added to c. The difficult part is obviously finding Okay, finding the right g of x to extract from your function. Often the asymptotic behavior of the function will give a clue. So for example, the RC becomes proportional to e to the power minus x squared over x as x becomes large. Therefore, use that. As the approximation form seems like an obvious thing to try, and does indeed all this. I already did all that. I want them to talk about relative errors. Okay, now I'm flabbergasted. I thought that this page was talking also about what to do in the case of relative errors. Yeah, it mentions it. Control F. Searching for column. What was on Reddit? Okay. So it's simply a redefinition of my E, basically. Instead of I do this, indeed. And that gives the absolute error, indeed. But if you just divide it by the absolute value of f, then you get a relative error. And then if you approximate that in the same way, then you have apparently the relative error. Apparently. Oh, if that's all. If that is all. Yeah, this is what I saw before. Okay. Now, therefore, we go to the previous thing, which disappeared. Oh, the smoothing function. There's one. Let's refresh my memory. Let's see what the thing did. Oh yeah, right. So I'm having a smoothing function, which seems to be disappeared. Huh? I think this is the smoothing function where the difference is multiplied by 100. Otherwise you would not even see that there's a difference. But subtract if you subtract the two from each other, then you get this. And then we can approximate this. So this is the absolute value. This E here is the difference, the plain difference between the real function and my polynomial approximation. And then we can do a few steps and it just immediately stabilizes to this polynomial. In this case we have a polynomial of only 3 degrees. Okay, maybe it's not times 100 because it's pretty big for 3, I think. Yeah, okay, so let's change this to relative error. However, this is the error function of the smoothing function, which is already not really the real value. And I think that my other program works out the relative error in the initial guess. Ouch. So I have to do some math here, I think. Okay, let's I'm just, I don't know, let's edit the roots. It's kind of a new subject though. Yeah, so we have a polynomial. I mean, we have an arbitrary cubic, but we can linearly scale that. Did we mention how that was called? There was a word for it, whichever called again. Well, let's say I call it linear. And then we end up with this one, or with a plus, but I'm only concentrating on the minus now. And then the root of this function, the most negative root, or the root less than the square root of, less than the minus the square root of 3, which always exists, can be written. So let's call that then R0, as before. And I just defined it basically as there was something with it. I don't want to redo that. Let's grab the sources for the cube root. Yeah, this one. Smoothing function tells us what it is. Sorry, R0 was our initial guess. So the root itself is, I just define that as this, and just by varying s now, you can always get the exact root. The beautiful thing is though that for small c0, the c0 is goes to 0, then s goes to 0, and if c0 goes to infinity, then s goes to +1. That's why I call it a smoothing function. It's switching between the solution that you have for a c0 equals 0, then the root is just minus square root of 3. And if C0 is very, very large, then the solution goes to the minus the cube root of C plus 1 over the cube root of C0. And then there is a small-ish area where that neither of them is accurate enough, and then we just pretend that we can build a solution by combining those two, by defining an S, and that works super good, because an S just really looks like a sigmoid. It's just, if the 0 is here, it's 0, and then it goes like, and it's a half at 0.9, and then it goes up, and then it's just 1. So it's probably 1 at 1.8-ish. Oh, totally. I mean, for the eye, you know. Okay, so much about S, but now we have a relative error in R. So how does that influence my S? And I have currently no idea. So let's just meditate on it a bit. Right, so you do some sanity checks. If C0 is 0, then S is 0, which means that we get out of this, this is 0 then, and this is then minus 1, so we get minus the square root of 3, which is correct. And if C0 goes to infinity, then the S goes to 1, so this is 0, so we just have minus, and this goes to 1, yeah, so minus that, which is also correct. And then I rewrote this, minus 1 is this, and then we have that times the plus the square root, and then minus the rest, and there I made a mistake. Yep, I knew it. That is also a minus. But now it is correct. So the S0 times minus that and minus that. Good. And now we saw that kind of independent of C0, at least, or the range that I checked, so between 0 and 0.9. The relative error doesn't change. Well, it did, but not that much, so we can just work with as if it is constant. I mean, hell, I could even make it not constant. Yeah, I mean, you have to stop somewhere, right? Otherwise, I'll the rest of my life work on this cubic. Finished. So I need an error that represents the relative error. Oh my god, I have no idea what I'm doing now. Why is this thing just not f? Why not just divide f by absolute value of f and leave that thing, and then yeah, approximate that. I guess the reason is I just want to scale the error. So you take this and then scale it. And the reason of that is that then oh yeah, of course. Well, R here, you try to get the error to go to 0, which kind of means that, well, I mean, you try to get error to 0, yeah. And if you succeed in that, then R should be, you want R to be equal to F, not something else. So you have to work with this difference, because R is trying to approximate F. But you're more concerned about an accurate fit if f is small, or the other way around. So that's why if you calculate the E then by dividing this this difference by the absolute value of f. Yeah, I think it's going to make the error, the E here, it's going to make the E equal everywhere. So that means that the delta here is smaller if the absolute value of f of x is smaller, and therefore it's a relative error. Now let's try to apply that. Let's hold on to that thought especially, and then try to apply it here. What is my f to begin with? No, I'm trying to approximate s. That's kind of, yeah. That's my f then. I'm not trying to approximate b. That would be silly. The whole idea was to approximate s, right? I'm just not happy with the error yet. I have to scale the error. Okay, so okay, so this r is the smallest root, and that's then also only a function of c0. So you can make this a function of c0. And I guess we have to I could express s in r now. Does that help me? Yeah, I think the scaling factor. The scaling factor has to do with how something changes as function of something. So that is it is a sum of some derivative ish. I think I feel stupid. I don't know. This is definitely not difficult. Definitely. Oops, sorry. Definitely not difficult. And yet I have a blank mind. Why? Okay, so I have a graph. Let's do a graph. Let's say this is my f. This is the allowed error. So I'm gonna call this f. And this FA of F approximated, and then we want FA min F absolute value divided by the absolute value of F to be more or less constant. Yes, yes. And now my case is everything is negative. So here minus the square root of 3. Yeah, that moves in some way, I don't know how. Close to cube root, I guess. Just something like this. Okay. And then the error now is also scaled by this distance. So we have, let's say this is twice as big here. So we have an arrow here, and then this is twice as big. So it's like there and there. And then again twice as big. And there and there. So my arrow looks like this. What is wrong with this pin? At some point I was so fed up with that the pen didn't want to write that I went to a shop and bought a pen of 35 euros. And now I'm not using that pen. Yeah. But I have the option to use it. So as soon as it becomes too bad, then I'll just get the other pen. Okay, so I don't know. Looks like nothing. So now this is R, and this is R0. And we want that R0 minus R, absolute value, divided by absolute value of R is more or less constant. Okay. This is my R, isn't it? Yes, it is. Okay. So I have an R here, and I have R0. Okay, that's R0, which is then not using the canonical S, but my approximation of S. Yeah. Let's just give it a different name. I don't know, W? W. Well, I think we got it. And just subtract these two from each other. So then we get R C0 minus that equals that minus that times that. Okay, what happened? Just one too many. No, can't be one too many. It's already. Oh, yeah, it's like this. So. And if we divide that, or take the absolute value of it, who cares? Absolute value of this one and the absolute value of this one. And is it not having a fixed size? I think it's square root of 3 minus that. How the hell is that square root of 3? Why is it not minus the square root of 3? Why? Well, because of this. But. No freaking wait. Is it? Oh, actually, yeah, it is. The minus here is this one. So, no, that was that one. Okay, yeah. This is just the part that cancels that part out if this is going to be important. Yeah, and this can become arbitrarily large. So the sign of this thing is depending on C0. You really have to apply an absolute value of it on it. Now I've got to wonder for which C0 the sign changes. Well, what happens if it is 0? Huh? That should then never happen. Can't cross 0 because it's unacceptable. It does not make any sense. I'll be right back. Okay, I figured it out. Always good. Some bathroom breaks. Helps make progress. I didn't get it at all, but it's totally true. If this cancels out with that, it simply means that this is equal to the square root of 3. So that it doesn't matter what the value of s is. If you change s between, if you write that out, you just get s drops out. This is totally not interesting anymore what the value of s is. And the result of that is that indeed the approximation can be anything. We don't care. Which means that it doesn't matter that... And I typed something wrong here. No, I didn't. So it doesn't matter that this goes to infinity, because, well, you can approximate with whatever you want. This is allowed to become infinitely large if you want, because this is now 0. And then what confused me was, yeah, but if for a certain value of C0 this is 0, then that means that my initial guess is always equal to the root. How is that possible? How can I guess the exact root? But that is exactly what happens, because R0 is calculated from this formula. So if you that would be that you get minus. Okay, now I'm confused again. Say, the square root of, if this is equal to the square root of 3, I should be able to calculate C0 then. And that ain't gonna be 0. I just have to solve this, I think. Okay, the decision to take arbitrary amount of time to solve this has been taken. Equals oh, so that is not possible. Nah. Did we make a mistake here? Okay, I asked for the square root minus the cube root of C0 minus 1 over the cube root of C0 equals 0. If that is not possible, then my problem disappears. I'll isolate the C0 step by step. Denote, why the hell? X equals the cube root of C0, which implies that the x to the power 3 equals C0. Substituting x into the equation, we get the square root minus x minus 1 over x equals 0. Yes, rearrange this to solve for x. X plus 1 over x equals the square root of 3. So just move stuff to the other side. Multiply both sides by x. X squared here. X squared plus 1 equals x times square root of 3. Move stuff to one side. X squared minus x times square root 3 plus 1 equals 0. Now solve for x using the quadratic formula. Yep, it is indeed. It can't be 0. Thank God. It can't be 0. Okay. I was somehow convinced that it could be 0. So strange. But. Why? This is so counterintuitive that it can't be 0. Oh, this is because of this, of course. This thing grows like, yeah, okay. So for very large C0, this is larger than the square root of 3. And this you can ignore that. But that means that we must make C0 smaller, smaller, smaller in order to try to approach the square root of 3. But before this one reaches it, it is already so small that this one starts to take over. And then you get negative again. So we never reach the square root of 3. Okay, I'm finally really getting it. It's not possible that this is 0. That's also some. That definitely solves something. So then there is always a relationship between my approximation and the R0. And my relative error is when we divide the whole thing by R, see? So divide this by the absolute value of R. And that's 2. And this is the relative error that we calculated. So we're going to state that we want this error to be, let's say, well, very nice. I wrote it down and then I make that paper disappear. It's laying on the ground, ready to be thrown away. There it is, 0.012. Oh, okay. Delete. So do this here. We'll do it here. I have 0. I need 4. 1, 2, 3, 4. Yep. And this thing must be larger or equal to the relative error. So this thing is the relative error, which is more or less constant. And this is the thing in my equations that I solve. So how do we scale the error, which is this difference currently, such that okay, no idea. So I can't get any further than this. So we begin now from the other side, from the web page again. So that was like, yeah. This is the only example I have, basically. I'm so stupid that I still don't get it. So this is the relative error that is more or less constant. Yeah, it's the same as this. And it's like literally the same, except that the absolute value is gone. Oh, the error is positive or negative. Yeah, we don't want to do that. That's true. Well, this must be large or equal. But if you talk about the relative error, then and it can be negative in this case. Yeah, it can definitely be negative actually. Yep, so here I have rel C0 is this without the absolute value. Read equals. Then I can just remove this. Yup, which is then this thing, which is bounded somehow, the absolute value of that. I guess that's what I have to do. Multiply, so you take this difference. I have to multiply it by that and divide it by that. Then we get something that is constant. That, yeah, that's it. That is it. Okay, don't need this already there. So now, let's copy this. I can change the smoothing thing. I think that is it to print something like the error function. But that is the error function, and we want to change that function. Yes. So there is E. And I think I only have that once. Oh, here's another one. What is this one doing in comparison to the other one? What is my initial guess? Yeah, okay. So we have to change both, I guess. But this just calls E of C0. I might as well redefine that now. Could call it E-rel, or just make it redefine E, I guess. And that is at least, that is done here as well. We plot E. If I redefine E, then how is that influencing the whole program? Yeah, the sign might change, so this could be problematic. No. No. I think E is just E. Yes, it is such that I just want to apply a scaling. A scaling that doesn't even change the sign. Now I realize it. I just realized. Well, actually, maybe it does because, well, I could, yeah. In case of the error, might as well then scale it with absolute value of whatever it is. And that takes place where I'm doing where I fill the matrix. I think, where do we fill the matrix? Here's the matrix. This is the E, the term for E. What about we just scale this? So isn't that what we should do? Well, it wouldn't be necessary if the input function was already scaled. That is true. But we might as well do it here. Okay, I'm gonna ask ChatGPT just to get some inspiration here. abstract is. Yeah, so this is what I thought. But then why would I have to redefine the arrow function itself? This is unreadable. No, let's just have it regenerated just based on this. This is wrong. Why the hell is it doing stuff like that? This is not the absolute value, of course. But yeah, okay, now I understand. We have to redefine that because we need to use this function at the moment. I'm looking for the local extrema. Okay, so yeah, I was right. I just have to multiply here with the absolute value of by scaling, which was this divided by that. I'm not feeling super secure about this. I think I checked it at some point, and why would it not pick up the square root from name? Well, it can't pick up standard name. Damn it, why am I even doing this? I was afraid it's gonna take standard square root, but I'm not using namespace standard, of course, so there's only one square root it can find. Or are you telling me that square root is dropped in global namespace as well? I hope not. Nah. Okay, so yeah, that's the square root of 3. I need the cube root of C0. Where's my C0 here? So not depending on I. Extreme X. That's the only thing I have. I think this is the X coordinate. The X coordinate of what? It's not like literally C0. Extremum. Yeah, well. Find extreme. Result X. X. X is X min and so on, which is positive for an extreme as the second and third. C min and C max. Yep, there we are. It is equal to C0. Boo boo. Where was I? Yeah, here. Mm-hmm. Okay, you need the root value at C0. The root value. How do we get a root value? No idea. Root value. Should be already calculated when calling S, I think. Or I have calculated them before. Let's look for S on the top. S is here. Yeah, U here. I think the U is the root here. Yeah, you do. You can only get the root by running Halley's method. I think that would always involve a name like this. And that only appears here. So I should just return the root together with this calculation, probably. Now I have to pass a root to the second argument to S everywhere. Yeah, probably dummy. And here I'm drawing it. Don't care about the root either then. sure I need a root at these values. That is that are the zeros. You have to redefine the. Maybe I do. Let's have a look what that is being used. Compute Newton coefficients. That's the initial thing. I don't think that changes, does it? No, it does not change. The extrema S values, that would be this is where I want to start storing the roots, I think. Not here. So yeah, we have an I'll put it outside of that. Another MP real root dummy. What was the dummy root? Dummy root. Nope, it was a root dummy probably. It's actually not smart. I should use I think a dummy by reference. Also in the previous case. Not sure which function this is. No, I can reuse it. And I reuse it here again. Just the place where we were. Okay, to here root dummy. Oh, but it doesn't give threading problems. I'm not sure which thread. I know a different thread is drawing, but I'm not sure if this lambda is going to be called by a different thread. In that case, it would be theoretically undefined behavior. There are two threads write at the same time to a non-atomic value. But in practice, it's not going to be a problem. At most, you get gobbled up root dummy, but who cares? I'm not using it anyway. So Oh, no, whatever, you just keep passing root in me everywhere. Now we are needed, so let's add here extrema root values. So then we store both the S value and the root that belongs to that one. What is this? Error function. That is the new error function. Which is then being used probably for here, also other calculations. No idea if this thing needs to return a root. Let's try to use the root value here again. So at extrema root, right? That is not not an extrema, I think. No, we're just even using it to plot stuff. It can be any arbitrary value now. Definitely don't want to use, well, hopefully I don't need it. Let's put it that way. But let's put it here anyway. Imperial, so a root value, whatever. So can you pass that by reference here. So now call to E also fills this root value. Well, that's funny. Now we're going to find the roots of E. Oh, the roots of E. Never mind. This is the totally different root. Okay. How many bloody calls to S to A? Oh, that was the last one. Thank you. Good. Then next, it depends on where we use these extrema values that we are filling here, because they now come with an extrema root values vector. We'll start at the top. That was that point. Here they are filled, and here we fill BI. Now we have finally the root. Because what the hell, extrema. I don't know. It must be Islam. Root value. No, I already used that. Extrema root. I, which we did not use yet, I hope. Let's I've used extrema root values. Yeah, okay, whatever. Extrema S values, extrema root values. And here I want to use extrema root, and that must be paired with extrema. Then what the hell is that field? So I did need that then. Extrema itself. Oh, this runs over all extrema. Oh yeah. I might as well store it in extrema itself then. So at some point we have a sign being assigned or not. Find extremum. Extremum is that. Doing that. Got to be kidding me, right? It was right there all the time. Or not. I'm not too sure now. Confusing. Using R for something else here. Yeah, this is finding an X coordinate, but it's not a root, it's just an extrema. So no root there. My extremas do not have a root. But here they are calculated. For a given extremum x, I calculate s, put that in extrema s values, and the root in extrema root values. And they are in tandem with the elements in extrema. So for every element in extrema, we extract x and determine the corresponding root. Therefore, extrema root values is what I want. So that was the scaling, but we also need to redefine the arrow function itself, so that well, that I can graph it or not is not even that important, but we are going to determine the well, the zeros is also not important because you can scale whatever you want. The zeros don't change. Yeah, but the minimum maximum will change. That's So let me think. Let's have a look how the zeros work then. I think this is zeros. It's a different zeros. Between two zeros. Nobody knows what that is about. This is find extrema. That is being past the zeros. So maybe I should just go to find extrema. This takes zeros. How many equals do we have to find extrema, by the way? 2. 1, 2. Yeah, this is the most important one. This one is the, again, the initial one. Difficult. I'm not, yeah, I don't know. I'm not convinced that well, probably I should redefine this as well. A bit confused though. I don't want to change my definition of S. If I change my definition of E, then S is not changed, right? No. E is just a function of, sorry. Yeah, E is a function of S, like this. So I can change E whatever I want. That doesn't change S. Okay. Yeah, okay. That would be the easiest thing to do. If I just adjust E here or below, and below, then the find extrema will find the extrema of that E, provided the zeros are still the zeros, and they are, because they don't change. So these zeros are determined how? Well, that's just a Chebyshev zeros. Yeah, so those are totally not interesting. And then we have another call here, which passes also as zeros. And those are find zero, also passing an E. So we just change the E lambdas. Then the find zero is still going to work and returning the same zeros. But and at least my find extrema will work. So I have somewhere above here, define E, which is a lambda, and then we have another one here. That's a comment here, and we don't have another one. So just 2, please. Fuck. No fuck. That was 94%. So this is, go from the top, we have 79%, a comment, and at 94% the second one. And then we go around. So there's indeed only 2. And they look very much the same. You just get past the C value, and then we call S. And we evaluate the polynomial P. Take the difference. This P is my W in the README. That's exactly the same thing. So let's just fix one and then copy it, right? I mean, it's really exactly the same thing. Well, not exactly, because this one uses a dummy. It's not really a dummy anymore then, because I'm going to use it now. Okay, it's temporary anyway. Yeah, I might well. But okay, so should undo. That's in advance. Define an MP real here. What you just call root value then. So we can do here also root value. And then we check again if they are actually equal. Yay, they are equal. So now let's fix one of them. And then the trick is that I need to basically, yeah, we need to, oops. Oh, that's easy. So just take the difference and I multiply it with something and then divide it by the absolute value of, yeah, the evaluation of P, which is maybe CPU intent. Well, it's not really, but let's just evaluate P separately first. And S also, otherwise I have no idea when the root is determined. So S of C. Let's give this thing multiple lines. Lambda. Indent. Oh, it's what we up again. Let's indent it. And then we have the PC and the S of C. Times the absolute value of PC here. And this is that factor. That is this factor again, right? Square root of 3, which I probably should calculate also outside. The cube root of C0. I'm gonna guess that is the C there. So we have to, we should calculate it also separately. The cube root of C. Cube root of C, 1 divided by the cube root of C. And then I want to have another square root of 3, I guess, outside lambda. That might already exist, actually. Yeah, I think this should be it. Yeah, I want to do it outside, so I'll just have to add it explicitly. Might have more like that. And I did capture that one. This one too. Or that was the one that I just changed, maybe. And then, yeah, maybe the root value itself. I've called that one. Yeah, well, this is just capturing everything by a reference. I think that does also p and root value then. Let's keep a bit track of what is being captured there. Oh, the square root of 3. Yeah. Yeah. Get the same list down there as in down there. Oh, another root value. Yeah, what? What is it? This is the one at the top probably. Find it. Nope. Other functions. This might be it. 85%. Very probable. This is a function or what is it? No, it doesn't look like it. Main. Yeah. I'm using the square root too soon. Let's move this thing up. Divide 0, some other stuff. Static? Nah, no longer necessary. Probably copied that from a function. This is just main. So now you have the square root of 3, which you then capture and use. And use again, and capture again, and then use again. Now, let the compiler figure it out. Compiler is figuring it out. Comes to the conclusion that I did not make mistakes anymore. That is, does it work? No, it does not work. I hate that. It should just work immediately. Okay, why does it do that? Zip. Zip. Up 7. Width. That's already kind of very small, really. And the height is 0, I suppose. Not a number. Now we understand it. Oh, that's my divide division by 0 problem. Yeah, I think I know what it is. ChatGPT talked about it. Yeah, I'll show you. It said that we must divide by the maximum of the absolute value and some epsilon in order to avoid the division by 0. So we have to find wherever we are dividing by the absolute value of whatever my function is called there. So ups something that I just added. No, find that back, not that. That. Yep, okay, so max PC and something that is very small but not 0. Let's call it epsilon, eps. So I'm afraid I used already epsilon somewhere. Might collide. Divide by the absolute value of PC or epsilon. Okay, and then we do that again somewhere. This scaling is okay because we're just multiplying by 0 and then not dividing by it, and this can never be 0 as we figured out before. But here we have it again to do the maximum. I'm suddenly not so sure about this, but okay. Eps. Maybe it is the error, maybe it is not. Probably it is. Whatever. What else, I mean? Could it be, right? Then I have to define an eps somewhere. And well... eps. I could just use the epsilon that I had there. Okay, just 79%. That's the first one. Somewhere above here. And here's my constants. Imperial const eps. Anything non-zero and really little. That should work. Theoretically, that should work. Theoretically. No, God, I have to. The list gets longer and longer. By now, this thing is allocating memory. Eps. Maybe it was already. I keep adding them. Or maybe I should just remove it. Use a single ampersand by now, since we grab everyone in the system. Ding, ding, ding. Okay. Da, 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 da. Oh. And it still doesn't work for the same reason. So that was not it. Still not a number. Now, figure that out. I have an offset of minus infinity. Yeah, where do we come from? Extends. Up. Bezier curve extends. Oh, well, that might be just because the value of the function is very big, like infinity big. I'm saying that the problem really lies in how we define whatever function we're trying to draw. This is add function, that is add function. F, okay, what is f? F is what is being passed. That is this thing, E. So E is infinity. Some point, or at least not a number. Well, that shouldn't happen. Not now we no longer divide by 0. What I'm doing with the max anyway here completely ruins for a large negative PC. We keep dividing by an epsilon. Yeah, stupid. Okay, let's fix that first. You never know, it might fix the bug. I doubt it. But yeah, this should be the absolute value of the max of the absolute value of PC, of course. An absolute. And this too. Absolute value of PC. And absolute. And max. Okay. And then at some point this turns into not a number. Why? So because maybe it's still, oh yeah, I don't know. No, wait a minute, it becomes infinity, which is totally possible because this is a multi-position reel, and then we try to convert it to double, which is not gonna work if you divide by 10 to the power minus 38. Well, yeah, I don't know. Maybe nah, on the other hand, it should still fit. You can go to powers like 200 something, 203. So, still no clue where the not a number comes from. Okay, let's do the following thing. MP real. Was it this one? I thought it was the first one. Not sure though. Let's try it again. Crash. I want you to crash. Yes, it crashes. Yay. Up. So. Up. 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 This is in main. Let's stop. Or not. Wait a minute. No. Yes, actually. Oh, yeah. Yeah. Now I remember the line number. We did all this. Quit. So it is this one. I'm going to do P real result is this shit. And then return the result. And then we're going to make sure that is normal. Result to double. Do I have a print in this thing? Yep. Make. And run and crash, and it is the assertion. Very good. Up so. And I typed all kinds of stuff in the wrong window. It is not normal because call print result minus infinity. That's the multi-precision is already minus infinity. Whoa. And why did that happen then? Well, this is made up from SC, which is 0, and PC, which is smallish, and the square root of 3, which is hopefully that, yep. Oh, the cube root is of course 0. So stupid, yeah. Cube root of C. Still trying to divide by infinity. Okay. Let's multiply above and below with the cube root of c. Times the cube root of c. Which means that we did divide by cube root of c. So now this must be multiplied with the cube root of c. And which makes this turn into a 1. And this turned into cube root of c times a cube root of c. And this a cube root of c times a cube root of c. Which means that I probably should just do that. And then multiply them both at the same time. That looks good to me. Yeah, let's just return it here. Return. Solution null fit. Yeah, 0 is not normal. Okay. Really not a test form. There was a test form, of course there's a test. I just ask ChatGPT, help me. You're my only hope. It's so brilliant sometimes. Not. So before it defined is finite itself, came up with that word. Not a coincidence. Defined it itself. And then I pointed out that this is finite exists. And then it just puts it here instead of actually using it. That was silly. Is finite. Okay, what's what you wanted? Assert standard is finite. Okay, not is not a number and also not infinite. And if it now doesn't compile, then ChatGPT made me look like a fool. But I think I remembered it. That it actually existed. Yes. And it doesn't crash. And there's your 2 to the power plus 35. So it's basically 0, you see? Around here maybe it goes to minus infinity, but no. Just ignore it and hit return. Oh, but the scales remains the same. That is not very useful. So it does correct it, but we can't see anything. The arrow, yeah, this is going to be super small, super small. And what the fuck happened here? I'm pretty sure it moves that way, meaning that the error gets larger and larger. Larger and larger and larger. Oh, well, okay. Maybe it makes the error super large here in order to reduce the error at 0. The relative error. Initially. But if you continue, then it should recover again, right? See if we can see that. Is it now going back or is it not changing? Yeah, it's definitely still changing. Yeah, no, this one appeared. Yeah, arrives at an offset of 0. Also very nice. Yep. Let's see what happens next. Oh no, it hangs. Interesting in itself. In clear. Oh. No, wait, it's a different clear. Never mind. S. Yeah, maybe S is never finishing now. Find extremum. Let's do some finishes here. Finish. That is not finishing. Find extremum is not finishing. Now we are in find extremum, and this is not finishing. Next. While call print x3 and 0. Pretty damn totally the same. But apparently that difference is still larger than or the other thing. Well, maybe it's definitely not larger than epsilon. Let's see if that at least that part worked. That's very yeah. Can't print that. Actually, I can maybe compare it. False. Okay. So this one is then the problem. Print f of 0. Big. Oh, it's just big. That's what it is. Yeah. It's so big that now the absolute an absolute value of tolerance it doesn't work anymore. This thing is small or super small. Super small. Super small. Oh, not even that small. But okay, that's just the square root of the smallest position that it has, I think. Not working. I have to multiply that with the... I think it's like relative, so you have to multiply it with absolute value of the function, I think, before. Or divide this by the function value. No, let's just multiply it with it. So I don't think I can do this, can I? You see, you can't do that. Oh. Can't do that binary op on that type. Well, I can, but you can't. The GDB. What is highly annoying. But we can print the very least this, right? Just the difference. Yeah, and this is larger than that by a factor of 200 and no 2 million. Oh, that's not even enough then, if you multiply it by that. Yeah, well, I don't know. It's just very inaccurate. Which makes sense, right? Because the derivative is like totally zero. There's no way you can get more accurate than about halfway the number of digits. It's even better than that. This value, there should have been like, yeah, this many zeros, and then let's say somewhere halfway in one. So the one should be in here. Here, I guess. Here, I guess. So why is it that? Say, if this is my accuracy. It looks wrong to being halfway. Where does this tolerance come from? 279. 279. And the tolerance comes from past to find extreme. It is this tolerance 335. And where does that come from? That's being passed also to find extreme. $580. This tolerance, which comes from what? This tolerance comes from tolerance deep. Yeah, that's bullshit. Why would I pass that? Could be. That's really, yeah, just some random value, man. Yeah. So, yeah, okay. So that's definitely not what we want to use here. How did we even think of passing that to find extrema? That's just so wrong. Find extrema. I thought I literally took a square root somewhere. Tolerance. This tolerance. Where does this tolerance come from? Nope. Also that one. Okay, let's search for all the square roots. Square root of 3. There, square root of tolerance, called tau, used in find extremum. I have my tolerance here, right there, it's called tau. And then I pass it as well. Oh, wait a minute, and then I take the square root of it. Okay, so I should be using tau instead of tolerance. Problem solved, yes, I think so. Yeah, that's the only one, obviously. I watched the platform, so yeah, obviously. Anyone else watch it? Did watch it? Tau. Epsilon is not x epsilon is used. Tau is used for x epsilon. Oh, what? Okay, yeah, maybe I'm mistaken. This is the yeah, yeah. Okay, now confused. I'm very confused. These two values, I said you could not get a very big accuracy, but the opposite is true, of course. Oh, wait a minute, this is not true. It is only true if it is a real maximum or a minimum, but this is probably on the edge where we have an especially around 0. Because now the thing is going to plus infinity, it is extremely steep. So tiny a little bit difference in x, even if it is around epsilon, the slowest thing, it's still going to be pretty big here. Yeah, okay, I think that's what I think now. So yeah, this should have been tolerant. Was actually correct. But you have to take into account that now my derivative can go to plus infinity. And I can check if that is the case by looking at the value of x min, I suppose. Gonna guess that x min is 0. Actually, both are almost 0. We're zooming in on x0. Already printed it. I think it was 0, but I'm not sure anymore. Why did I not just type what? Up 7 and then you get what? It's not. Did it not run into an assert? No, it did not run into assert. It was just hanging. Stupid. No, okay. This is the frame. Yeah, I'm still running it. And here I want to print x min, and I predict that it is 0. It's not 0. Well, maybe it's 0 enough. And yeah, I mean, put it like this. Oh, that is big. No, that is pretty strange, if you ask me. That is pretty strange. Yeah, the derivative must be like huge, because these values are the same when printing it, and still the function values are different, significantly different. Hello, Albay. If you put the word else in it, then it's definitely a insult, or maybe this is a better word. But I'm not sure what you exactly mean. Normally, I feel my IQ decreasing when I look at something very stupid, so that's why. But it could also mean that you think, in comparison, you feel dumb. That would be a better expression, I guess. In which case, I would say thank you or something like that. I think I should go to bed. It's midnight. Probably not going to bed anyway. I'm going to play chess first. And this is, too annoying to continue right now. Well, you should do that a lot, feeling that pressure on your brain. How old are you, if I may ask? You're probably too old already. I have the feeling that the kids and teenagers of this generation, way too old. So you don't have a mental, what is the word? Uithoudingsvermogen in English. I really don't know. ChatGPT knows. Endurance, I know it. So mental endurance. I told this story before, but at least in my case, I was always thinking deep, to the point that my ears were always red and hot, because I use them as cooling fins for my brain. And I have been around youth when I was already an adult, because helping kids with psychological problems and stuff like that. So I know a little bit. I don't know. I see a difference. People just, especially if you look at what is on social media. It's just so short attention span, but also people that young people that I speak, they don't like to feel tired in their brain. They think that's not normal, and they immediately stop with learning. Yeah, my IQ is very high, but I don't even want to say it actually. I said it before. I'll type it, so I'll type it instead of saying it. Somehow, so go. So yeah, but the genius level, I've always got that back. Every time I was tested is off the scale. I mean, not I have not been tested over a long time, and I wouldn't want that because I feel so stupid these days that I would just be afraid that it is really low. But yeah, well, I'm not impressed by Einstein. I wouldn't be surprised if I was at least as smart as Einstein. But you're right. He had they said he had an IQ of 160. But if you really read up on what he did, isn't even that impressive in terms of. I mean, he had a few simple ideas, and then he just worked on that tirelessly for years and years and years to work that out. Anyone could have done it. Because you still need the ideas, and you still need to hold on to it. I doubt that. You wouldn't be able to type if you. That's true. Well, we were talking about the younger generation. So, in my opinion, it is such that if you try to learn something new, then you will get tired. And that feels very nasty. It's not a nice feeling. But if you immediately stopped when you feel that, then you don't use your brain. So you end up, yeah, more stupid and or at the very least having no endurance. So I think that kids and young teens they should push themselves to use the brain a lot. And I know that what I did was the whole day non-stop solving problems, the same as what I'm doing now, basically. I never stop thinking. So I hardly know what it is to get tired for that reason. But what I hear is that there's a YouTube about it by Veritasium, which is correct, strikingly correct. I'll accept that. Of course, I have no idea. But it would be a nice check if you can search the web. If you can't find a YouTube through ChatGPT. So can you find YouTube of Veritasium? Sorry, how you write it? Oh, where he talks, I guess, about how the brain gets tired if you learn something. The only way you can find that is if you have transcripts of all the YouTubes, I suppose. This might be it, right? Yeah, probably. Yeah. Well, the way he describes it, definitely. Yeah, yeah, that's exactly it. So that is super good. You can use ChatGPT or stuff like that. So watch that. That's a YouTube that I could think of that explains this a little bit. And I have the feeling that kids of these days just run away way too soon. They don't have they are not in the habit of keeping at it. If you understand what I mean. Maybe it has to do with social media. The short videos they're so bad. I hate YouTube for showing shorts to me. I don't want to watch them. It's really bad. Just too short, and you just keep swiping. Horrible. You have so much information these days that you can. That you only have a very little time for each of them. At least, yeah, that's how it feels. So let's say kids grow up with social media, and my friends have WhatsApp, and then the other friends also, and I use also Telegram, and I use Signal, and then I have to keep up my Facebook and read the Facebook of all the others, and it's so much that you only have 1 second or 2 seconds time for each message or page or whatever thing, and then actually you don't have any time at all, so you don't read anything anymore. You just look at the image, and then you press like to let your friend know that you looked at it, and they did completely unlearn sitting down reading something until they understand it, in my opinion. Yeah, I was going to stop. Let's lose a game of chess, and then I'm definitely off to bed. The why not move. Okay, he doesn't fall for it. No, it does. Do you go here or go there? We go here, he can't attack me because I would just take the pawn. So he probably pushes this, and then I take his pawn. Then he could attack my knight. After which I have to go to the corner, and then he can sacrifice exchange the bishop, have a double pawn here, not good, but an open file. Then he takes back. Yeah. And if I go here, I'll block my bishop, and he could push and then have a double pawn in the center, which is also not very nice. I think I'm just gonna go here and see what happens. Yeah, that was expected. Now we assume that if I take here, he just... Oh, I take like that. Oh, well, maybe why not? But you cannot double my bonds anymore. I'm just doing this, and then I can go there, right? Na. Now we created a weak pawn here. Well, a backwards pawn anyway. Okay, so besser the pawn here. Oh, right, yeah, true. No, I can go here actually. So now I'm threatening that pawn. Isn't that exactly what I wanted? No, I can attack it even another time. And then we can threaten something maybe. Do I do this? Yeah, it's not a bad move. So scared. Could just put the knight in front of it if my bishop goes here, but no, I had to defend it. Okay, let's develop this thing. And let's take the bishop maybe? No. 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 I don't know. Castle. Or does my bishop something here? Not really, but yeah, we have to do something about it or not. No, I have to attack this. This is what I have to attack. So this bishop belongs like all the way over there. I don't want to castle that way then. Let's try castling this way. Maybe it should take here this and I'll put a bishop here. Maybe. I do that now and he castles and he has a rook here. Oh, it's not what I want. No, let's just put this thing here. Or, yeah. Threaten to push this pawn. Is that a threat? No, why not? I want to get rid of that pawn. No, I don't want. Wait a minute. I don't want to get rid of that pawn. He just takes back like that, and everything. My queen is attacked. It's so horrible. Let's exchange queens. Let's exchange queens anyway, because that seems to win a pawn or two. Yeah, this pawn is now for free. I'm just gonna take it. That should win the game. No, he's gonna take. Otherwise, I take here with. Let's check. Okay, I'll take back. Now he's gonna take exactly. He helped me double my rooks quite easily. You want to take here? Okay, no problem. Shall I first do this on, or first, as we do this on, he take, check, gone. That's not good. Put it on here, same thing, but I can put my rook in between. It attacks my knight, however. I just take my second pawn. Let's just do it. The other thing is protected. He takes, I take, and then he takes my pawn. Is that the trick? Never go here, he could attack it, and then go back. Oh, I can try that. Everything is defended. Oh, maybe not. Oh, I had not seen that. Totally doubled my pawns and won a pawn. He did win a pawn. Going to promote. Attack. Problem. Let's develop this first then, maybe. Yep, I'm attacking it twice. He has to move his bishop. Please undouble my pawns. Please. Please. Undouble pawns. Oh, he's going there. Well, then I put it here, right? Feel free to undouble my pawns. Oh, is that the right move? Actually it is. Well, check, pawn forward, go here, pawn forward. Stupid moves. Could just defend it like this, or I can attack that one first. Probably the best move. 35 seconds. How did I do that? Okay, now go here. And now I'm still not threatening anything, really. Oh, give this pawn away. Well, not really, actually. I win this pawn back. Maybe even more than a pawn. I'm +3 now. How did I do that? Here. The very idea, yeah. The man's got a point, huh? Definitely got a point, huh? No, that cost you your bishop, Mr. Resign. 1 point for Carlo. Yes. I want to rematch. I definitely want to rematch this guy. Of course, the only true way to win is... Oh, I thought he went offline. I want to win in a way that my opponent goes offline. That's the only way to really win. But it was a fake. Let's see, what should I do here? Probably is this, which is not very good. Certainly not if he takes my knight first. Most people, however, take the pawn. Yep, that is wrong. I would like to prove this. How? So we go here. Wait a minute. I can just take this ball. What the fuck? I don't know why, but I take with the bishop. And then he's castling and I have nothing. Well, I have the center, but yeah, theoretically, basically nothing. Damn it. One of these days I will can go here, and he pushes this pawn maybe, and then I give check. And then he moves the king, and then I lose. No, then I go here, threatening mate. So he takes and I take. Oh, wait, I go here, I mean, threatening mate. Take. And then I threaten to go here and give mate, so he plays a rook. No, it's nothing. Nothing. It could develop like this. He plays this pawn. I don't really want him to take, but what else can I do? This is going to hang then. So he plays this pawn, I take here, and he takes like that. Then I take. No, I don't. I think this is a good move anyway. I'm running out of time here. That pawn. That can't be right. Totally can't be right. Now he does that. True. True, my friend. I'll go here, and then he goes back with the bishop. And then I'm not having much. I'll have this bishop, of course, and take that one. If he does that, I just take it. And then he has to take back with that pawn. That would be pretty bad. I'd still do that. Before he gets the idea to move the bishop backwards. Or I can just play this, threaten mate. Because if the bishop went back, it was out of the question, but now I can do that. And he has to play this pawn forward, which is pretty damn bad, I think. That is really bad. That is definitely really bad. So I'll do this. And now he plays this knight, thinking I have to move the queen, and then I will move my queen over there, giving mating one. Now he's going to play this pawn. Nobody with who is that stupid would call himself mole 1. See, that did it. But now the bishop threatens to come here. I think I want to stop this from happening, or let it just happen. Let it happen, and then just move the queen. Move the queen here, or here, yeah. Oh, I almost gave a pawn away. 2 pawns. You can just take it, and then I take a bishop, and he takes the other center pawn. That wouldn't even be that bad for black, I think. Oh yeah, okay. So the bishop hopefully is going that way, and then I can go here, and I'm threatening mate again, and he can't push it once, so he has to push it 2. And then he's going there. I'm shocked, seriously. I'm really shocked. I'm just going here. I'm not even thinking. What is this guy doing? Okay, I have to go back. I admit defeat. I'm trying to take your pawn. Do something about it. I suggest pushing that pawn forward. Yeah, I thought so. I saw that coming. Okay, I have to keep defending this one, which is kind of unfortunate. Let's go here. Now we're going to push this pawn. He wants to go there? Nah, I push this pawn, obviously. No. Let's go away. Push this pawn. What can happen? It's only the king here. What? No. Like, go away? No. Yeah, that's what I thought. Oh, I can't push my pawn now. Damn it. Okay, that was unexpected. Shit. Well, I can actually. He takes it and I take here. Might not even be that bad. Let's just do it. Oh, I lose this pawn then. Oh shit. But now I have an open file. Yeah. No. Okay, I have no time left. Let's give away this pawn. Oh, this is on the same line as my king. It gets worse and worse. But I'm attacking his rook, so maybe he doesn't take it now. And then I can go back defending it. Haha. Can go back. And now I'm threatening to do I have any threats here? Not really. Okay, that thing is unprotected, and that one too, and he's threatening to go here. I just have to go there, and he can still go there, because the bishop is here. Shit. Maybe one further was better. I'm gonna kick the knight. The knight's gonna go here. Knight is already there. Okay, trying to take my unprotected bishop, which protects this pawn. That sucks. So what do we do about it? Well, we defend the bishop like this. Like this? Yes, like this. And then I'm fucked. He just takes it, and I take it back. He takes here, and I can't take the bishop because the knight is pinned. Oh, I didn't see it. Well, that's pretty good. Now I can defend this pawn. And all problems are solved. I almost lost. I think he felt that his clock was almost running out. Therefore, he did a very quick move. Right. Yeah. Kind of not nice. What about this move? Did he take something? Jesus, I don't even know. He took something. Something, not really. I'm gonna take here. Oh, that was wrong. He take no. Actually, it is not wrong because if he takes here, I take the bishop again. 10 seconds. My God. Double on attack on this pawn. But yeah, I can do that. No bots there. Problematic. Very problematic. Check. Okay, let's go to the 7th line. That can't be right. That can't be right. I just take here, threatening mate here. And then we give check. And then we push this pawn. And now I'm threatening mate by giving check here. Or not. Well, probably. Yeah, so give check here. He must go back, otherwise it's mate. Oh, idiot. Actually, I want to analyze this, and I have to go to bed anyway. The last move. It's made in 6. If we can one goes that way, it's also 1. Check. Oh, I have to push the pawn. Oh yeah, of course. I can just promote here with the queen. Should have done that immediately. For some reason I didn't see that. That did win. I'm going to bed. Good night, single viewer that is left. Delete. Let's delete this all.